All right, this first question, you just got to know what a function is. And a function is a relation that pairs each input with exactly one output. So if you're confused by that, I like to do a graph sometimes. So let's say here's my y-axis, here's my x-axis. That 0.25 would be 2 to the right of the origin and then 5 up. And then the 0.35 would be right next to it, and 4 or 5 next to that, and 5, 5, and so on. This is a function because it's a horizontal line. You just can't have it be a vertical line. So this is a function. And then if I look at the second example here, this is not a function. Each input does not have one output. This has two outputs. The last one, there's 4 different inputs. So it's okay, again, to have 2 different outputs right there. That if we were to make another graph here, the 0.11 would be right there, and then the 0.22 would be there, the 0.32 would be there, and you can see that we're not getting a vertical line. We are getting, looks like a trapezoid almost. You're not going to get that to be a vertical line though. So that's going to be a function. Each input does have one output. So I would say graphs 1 and 3 in this example are functions. For number 2 right here, this, again, we go to the vertical line test. There's no vertical line at any point here. There's no point where, or points I should say, where there's a vertical line crossing 2 spots of it. You can see these are vertical lines here. It never happened, so this is a function. Number 3, does the input-output table represent a function? Again, each input has one output. I would say that is the function. In terms of listing the domain, a couple of answers that I would have accepted here. This happens to be a situation where you are multiplying by 5 each time and then subtracting away 1. So the rule here is that y equals 5x minus 1. So I would have accepted all real numbers for x. You could also say x equals 3, 4, 5, 6. I think the best answer though is that really x is all real numbers. And same thing with y, the range is all real numbers. But if you listed them as 3, 4, 5, 6, okay, 14, 19, 24, 29. I skipped 24. But I guess what I'm trying to get at here, they don't specifically say that this is definitely linear. So it could be referring to just discrete points. Maybe it's only looking at a 3-year-old, 4-year-old, 5-year-old, and 6-year-old in the data. I don't know. So you could make an argument for me that the domain is 3, 4, 5, 6, the range 14, 19. I should have put 24 there, but 29, 24. And I just went over the range there and the domain. So this one right here, it says which data set is described by a linear. Linear means the slope doesn't change. So as I look at these, I'm going to skip to letter D. The change in x is 1. The change in x is 1. The change in x is 1. Okay, that's seems to be pretty straightforward. Let me use a different color here. The change in y is negative 1, and then it's positive 1. Right there, the slope change can't be D. If I look at letter C, again, x is changing by 1 each step, and y is changing down 6, down 6, down 6. I would say C looks good. For this one right here, it looks like x is decreasing by 1, so that's constant. Y is increasing by 1, y is increasing by 1 again, and then right here, it decreases by 1, so that doesn't work. Lastly, this one right here, x is increasing by 1, but y changes. This would be actually a quadratic function. It's going up by 5, then by 7, and then by 9. So there's a pattern there, but it's not a linear pattern. Number 5, is that a linear function? Again, I think this is similar to the one we just saw in that multiple choice. The outputs are going up by 16 and then by 11. The input's going up by 2, then by 1. So let's see, this is 16 over 2. That's the slope there, up 16, up 2. And then if I compare that to up 11 over 1, those aren't really equivalent, so this wouldn't be linear. It looks like it's a function, but not linear.